What this video is going to help us understand is going to be the multiplication of polynomials. This is going to be a set of videos with the different situations that we may encounter. So the simplest situation that we're going to encounter is when we multiply a monomial times a monomial, two monomials. So for example, if I have something that looks like 6x to the power of 4y squared, and I'm multiplying this to 3x to the power of 7y. This is a multiplication of two monomials. There's only one term on the first parenthesis, there's one term on the second parenthesis. So that's why this is a monomial times a monomial. So now just to recap into areas. So for example, if I have a square, and the length of one of those sides is 3 centimeters, and the length of the other side is 2 centimeters, how do I find the area of this square, right? This area over here. So what you have to do is you have to take both sides and multiply both sides, right? Which is going to be 3 centimeters times 2 centimeters. And this is going to give you the result of the area, which is going to be 6 centimeters. You just multiply the numbers. So this area on the center over here is going to be 6 centimeters. So we're going to take the same approach to the multiplication of monomials and later on into polynomials. So can we think about a rectangle? I'm not going to say a square, I'm going to say a rectangle, in which one side is going to be 6x to the power of 4y squared, and the other side is going to be 3x to the power of 7y. So can we find the area of this rectangle? So this is what we're going to try to do, right? Try to find the areas of rectangles that have these lengths over here as sides. Okay, so in order to do that multiplication of monomials, I'm going to write my example again: 6x to the power of 4y squared. And to this I'm multiplying to 3x to the power of 7y. So what we have to do in this case, this is slightly different than combining like terms or addition of polynomials. We have to multiply the coefficients first. So numbers are going to multiply each other's. So 6 times 3, that's going to be the first part of the result. The second part of the result is multiplying the x's, use the x's times the x's. That's x fourth times x to the power of 7. And then the third component of the result is going to be multiplying the y's. So y squared times y to the power of 1, or y, just y by itself. Okay, so let's see what the result is going to be. So big numbers are multiplied normally, so 6 times 3, that's going to be 18. And then letters, when you multiply two variables that have two exponents, this you can do. So you're going to keep the base always. If you're multiplying x's, then the result is going to be an x. If you're multiplying y's, the result is going to be y. Okay, if you're multiplying xy's, the result is going to be xy's. Okay, now we have to play with the exponent. So when you're multiplying variables, all you have to do is add the two exponents that you have in there. So 4 plus 7, and that's going to give us our result. And the same is going to go for the y. So you have to add those two exponents. So my first exponent is a 2, and the second exponent, people tend to confuse this with a 0, but in reality, when a letter does not have an exponent, or it doesn't show an exponent, it does have one, which is number 1. Okay, if that exponent were to be 0, then it will be written. Right? If a variable has an exponent of 0, it will always have that written. Okay, so if it doesn't have an exponent showing, that exponent we have to assume that's a number 1. Okay, and then you can just do those small additions. So 4 plus 7 is going to be 11, and then 2 plus 1 is going to be 3. And this is my result. And in terms of our square, it means that my area of this, this rectangle, I think I previously said a square for the first one, that's also a rectangle. Okay, so the area for this rectangle is going to be 18x to the power of 11 y cubed. So that's the area of this small rectangle. So let's take a look at another example, another rectangle. I'm just going to call those rectangles from now on, trying to find the area of those rectangles. So this is the rectangle. I'm going to do multiplication of monomials again. My problem says 6x to the power of 5, y to the power of 7, and this I'm multiplying to negative 3x squared, y to the power of 4. So I'm doing this multiplication. That means that one of the sides of the rectangle is 6x to the power of 5, y to the power of 7, and the other side is negative 3x squared, y to the power of 4. So we're going to try to find what the area of this rectangle is by multiplying those two sides. So let's see what we're going to do over here. So the first thing that I'm multiplying is going to be the normal coefficient, the big numbers that I have in there. So this is going to be 6 times negative 3. Just going to use the parentheses. 6 times negative 3. This is not a subtraction, this is a multiplication. There is nothing in between those parentheses. If there was a plus sign or a minus sign, then that would be a different story, right? So that's 6 times negative 3. That's the first result. Then we have to move into the variables. So we have x times x is what we're going to multiply. So x to the power of 5 times x to the power of 2. We're multiplying those two variables also. And then the last multiplication that I'm going to do is the y's. So y to the power of 7 times y to the power of 4. So we're doing this multiplication separately. So the first result, that's going to be negative 18. 6 times 3, that's 18. Negative 18. The x component, that's going to be a 5 plus 2. Since I'm multiplying those two x's, I have to add the exponents. And the y component is going to be 7 plus 4. And I also have to add those two exponents, the 7 and the 4, on top of the y's. So let's see what the result is. That's negative 18 x to the power of 5 plus 2, that's x to the power of 7. And y to the power of 7 plus 4, that's y to the power of 11. This should be my result of multiplying two monomials, right? That's the area of this rectangle that I have in here. So this is basically multiplication of monomials. In the next video, I'm going to show you how to multiply a monomial times a polynomial, which is going to be this exact same process, but several times repeated in the same problem. Okay.